So it starts off nice. What's the answer to this one? 2. Because 9 squared is 81. So that's the answer is 2. Here. Careful, 10 to the 100th power would be 10 times 10 times 10, 100 times. Holy shit.
10 to the third.
10 to the third, I like it. So, since 10 cubed is 1,000, therefore this has to be 3. Be very careful, this is not enough for the answer. This is work, this is answer. Now that I've given you a way to think about this. Now, this is kind of cool. Do you see how, real quick, I want to show you this. What would log base 7 of 49 be? 2. What would log base 7 of 7 be? 1. What would log base 7 of 1/7 be?
-1.
Alright, so see how if the inside is the same, it's 1. If the inside is bigger, it's an answer bigger than 1. If the inside is less than 1, it's going to be a negative power. That's the only way to make it flip and become less than 1. Nifty. Again, you have to understand what I just said. Not really, but it's a neat thing to kind of keep yourself straight. So that would be 2. So that has to be, like you said, -2, because 7 to -2 is 1/4. So 1 over something will definitely be a negative power. Let's see. This was a 6 to, yeah.
0.
Here. 1.
The next one.
Oh, sorry. Yeah, because anything log base b of b is just 1. I like it. Yeah, log base 5 of 1, the only way to get a 1 out is to have a 0 power. I love it. Yeah, this one is interesting. So, that thing I was showing you earlier, do you see how this number is less than 36? If it was 36, it was log base 36 of 36, what would the answer be? Just like the log base 6 of 6 is 1, log base 36 of 36 would be 1. What do you raise 36 to make it 36? You raise it to the first power, right? That's less than 36, so the answer has to be less than 1. It's got to be a root. What root do you apply to 36 to make it become 6? Square root. And square root is a what power? 1/2. Cool. So right on the heels of that, what do you think this is? Log base 27 of 3. That number is less than 27, but more than 1. So the answer has to be some kind of a root. What root do you take on 27 and make it become 3?
1 over 3.
A cube root, which is 1/3 power. Kick ass. So sometimes you got to think, if that number is smaller than this one, but bigger than 1, because if it was 1, the answer would be 0. Smaller than this number, but bigger than 1, it's got to be some kind of a root. The answer is going to be some kind of fraction. I like it. Here's another way to think of it. 3 to the third is 27, so 27 to the 1/3 is 3. You can kind of just invert it like that. All right, here, this one.
5.
Yeah, this is one of those silly ones. What do you raise 11 to make it 11 to the 5th? Well, 5. Holy shit. And then this one. What about this one?
-3.
Yeah, you got to raise 3 to the third to make it 27 and negative to make it flip. And this is the one that everybody loved, and I don't blame you.
No solution.
No solution. There's no way in hell to make it become 0. Or make the inside 0, right?
Could you write undefined?
Yeah, undefined. Yeah, if you put no solution, I'd be okay with it, but it's not really an equation. But it really is undefined. I like it. Again, if you bring complex numbers in, who knows what could happen, but we're not going to. How do you guys feel about those? It really isn't as horrible as people often think. Yes? No? I love you guys. You're all like, whatever, man. Whatever makes the final come quicker. Let me start my Christmas. All right.
Aren't we going to do the top?
Say again?
Aren't we going to do the top?
Oh, yeah, the top thing. I knew there's something somewhere. So, now watch this. Why is this true? Is this true?
Yes.
Why?
Squared is.
Because 5 squared is 25. So you can always rewrite logarithms as exponentials and vice versa. Vice versa. So here, log base 2 of 8. Now watch this. Here's how this works. Why is this true? Because 2 to the third is 8. 2 to the third is 8. 5 squared is 25.
How do you switch it back?
Say again?
How do you-
All right, now we're going to do it backwards. You ready? This is the harder way. But can you tell me what the base is in this? What's the base? 3.
Log 3 equals 1 over 9.
Now what's the input on this? What's the power in this? Negative 2. So the log is supposed to equal a power. And 1/9 has got to go in here. 3 to the negative 2 equals 1/9. Kick ass. Do you guys see that? So it's always harder to go back to logarithms. It's just kind of freaky, but this is the base. The answer is the power. And then the thing over there is that's the only place. And they're inverses of each other. So if 1/9 is the output over here, it's got to be the input over here. They're inverses. X and Y switch. Output and input switch. So you guys do this one. Don't say it out loud. Change it to a logarithm. Okay, so what do you get? Log base what? 64. What goes inside? 8. 1/2. I like it.
How does that equal 1/2?
Because 64 to the 1/2 is 8. What's the 1/2 power?
Oh, okay.
Yeah. So the answer is always the power. The base is the base. And the output becomes the input. Because these are inverse functions. You guys look tired, but we're gonna keep going. Holy shit! Let me give you this. There's one side that says 12.3, one side says 12.4. I'll start with 12.3. Okay, so there is a certain base.
Oh,
Well,
one of those.
I missed you. How did I miss you guys? Don't take it personal. Good. Alright, I need some blank paper somewhere. Give me blank paper. Do I have any blank paper? Yes. Okay. There's one piece of this that we don't know yet, and then you can do everything else on this page. There's a special base in between 2 to the x and 3 to the x. It's special for quite a few different reasons, but if I were to throw a couple rabbits in a room with some food, what would happen eventually? They would probably procreate, right? They would make little rabbits. And then unfortunately, you don't want to think about this too much, but they would, go at it. Don't think about brothers and sisters. And they would make more rabbits, and more rabbits, and more rabbits, and more rabbits, and more rabbits. Keep throwing some more food in there, and they're just going to get, look, they're going to grow how? Like that, right? As long as there's no wolves in there or something weird room.
Another bunny from Monty Python.
Yeah, run away. I love it. The hand grenade, the holy hand. Alright, stop.
What?
The numbers are not exceed. Yeah. Alright. Sorry, it's so easy to get me off track. There's a number between 2 to the x and 3 to the x. So here's 2 to the x, here's 3 to the x. Oops. There's something right in between there. There's a number right in between 2 and 3 that is used to model population growth. And if you look at the other side, what happened in Chernobyl? You guys know the name Chernobyl. It's not just a stupid horror movie. What was a horror movie based on? The fact that there was a huge radiation leak. It's going to be thousands of years before it's safe. And why is that? Because the radioactivity has a certain half-life, right? Not just a video game. But so over time, the amount of radioactivity decreases and decreases following this shape. So either you have population growth, or you can use the same shape for radioactive decay. I love that shit. There's a number, again, between 2 and 3 that so perfectly captures the increase and decrease of things. And it's a lot like we give it a symbol, sort of like we gave pi a symbol. What's pi? 3.1415, that's it, blah, 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 forever, right? It's not just 3.1. This thing goes forever. That's why we gave it its own symbol, because it's so amazing. This guy, we give it the symbol E. And E is approximately 2.7128, blah, 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 blah. Same thing, sort of like pi. And so it's just a number. It's just like pi. It's just a number. But it's kind of a gross number. So if I said E squared, you would need a calculator to do that, right? So one thing I want you to realize is, okay, so if I have 2 to the x, what's the inverse of 2 to the x? Let me see if you guys can answer this right now. What's the inverse function of 2 to the x?
Log 2.
What's the inverse function of 3 to the x? What's the inverse function of e to the x?
Log EX.
I'm only going to write this once. It hurts me to write this. We write this instead like this. Let me tell you why this. What does E do fundamentally? It models natural phenomena, right? Rabbits going at it, radioactivity decreasing, right? It models natural activities or phenomena. This is an N for natural log. This is natural log. Because it's the logarithm that it's the related to the base that models natural phenomena. You guys, I'm just trying to tell you why this symbol is this. That's why it's ln. It's a special thing. It's it's E. It's special. So I got to call it ln. So when you see ln, you know it means log base E. I'm not going to say this or write this ever again for you guys. It hurt to do this. That's what it is. So real quick. So watch this. If a question I had was natural log of e to the 7th, can anyone tell me what the answer is? How do natural log and e, how do they relate? They're not equal to each other, it's my bad, but they are inverses of each other. So what would natural log do to e? What do inverses do to each other? Kill each other. So what's the answer? 7. And again, remember, what's the base of ln? What's the base? I can't say it. I told you I was not going to say it. So what do you raise e to get e to the 7th? Freaking 7, right? But I prefer this, die. So e is a number like pi. It just kind of came out of a few different places in math. Holy shit, this number keeps showing up in these weird things. And they modeled rabbit growth and decay and all that kind of stuff. So he gave it the symbol E. Euler gave it the symbol E. Not because his name is E-U-L-E-R, because E was the next letter he was using for all these things. Right? So we're all Euler, E, when you used E. He's like, no, he already used D, so he used E next. You guys didn't want to know that, but too bad. All right, so let's do a couple of these together, because we are running out of time very quickly. How do I write this in exponential form? What's the base? 3 to the what power? 10. See, I can always draw these arrows. 3 to the 10th equals y. Cool. Did we just solve this equation? Do you see how we just solved it? What's y? Well, it's 3 to the 10th. So just by rewriting it, I can actually solve some equations. What about this guy? Careful. No. It's already an exponential. I need it in a logarithmic form. So what's the base?
ln.
Good, I like it. I was going to say, I'm going to start at the log, but I'm not going to write it. The base is e. What's the power?
5 points.
What's the power?
W.
W. And what's the output is 5.6, so now the input is 5.6. This is used a lot. That's why I didn't want to let you out of here before we talked about what the hell ln meant. All right, now some of these we already did. We already did this one. What is this? Natural log of e to the pi. What is it?
P,
Who?
pi, how do you guys
Pete,
say
pi, po, pum. Yeah, what do the ln and the e do to each other?
cancel each other?
So then the answer is pi.
Pi, yeah.
Don't call it Pete. I'll take it personally. We've seen this one enough, right? What's this? 0. Now look at this one. Now, okay, all right. Here's the other piece. Which root do I not write a number in? Which root do I not write a cube root? No, there's a little 3. Which root do we not even write the number?
Square root.
Square root, right? Why the shit is that? Why does every other root get a number and the square root's like, I don't have time. Because the square root is the most used root. We live in California. You guys know about Richter scale.
Yeah.
What does it measure? Strength of earthquakes, right? So that uses log base 10. So the same way that a square root, we don't put a 2 here. When you see, look at this log, what's the base? It looks like there's no base, but it's understood to be base 10. Why would we have a base 10 that doesn't show up? Why would we use base 10 the most? Because we have a number system based on 10, because we have 10 fingers. If we had 12 fingers, we'd have a number system based on 12. If you took my 120, you'd see what that looked like. We'd have to use letters for numbers. Oh, shit. But, so when you see a log that looks like it has no base, it has base 10. When you see a root that looks like it has no index, no root on it, we know it's a square root. There's a 2 there, right? So, what do 10 and log base 10 do to each other? What did these do to each other? Because it's log base e and e. What did 10 and log base 10 do to each other? So the answer is 4.
So just always assume that if you don't see a base, it's 10.
It's known that it's base 10. The same way, you wouldn't say assume that's a square root. You know it's a square root. Because if there is no number, we know it's a 2. If there is no base on the log, we know it's 10.
So for all of the other,
Yeah, if it has a number down there, it's that log. If it doesn't have a number and a base, it's 10. We just don't write it. Same reason we don't want a 2 in a square root, because it's the most used root. This is the most used logarithm, log base 10. In fact, in the book, if you look at it, it's called the common logarithm. Oh, we didn't want to like this. What do you think about this?
1 over 4?
Yeah. How many parts do I have to break 16 up to get to 1/4?
Yeah.
Uh-oh, so now watch this. 16 to the 1/4 is 2. So how do I make it become 1 over 2?
1 over 8?
No.
Oh,
Negative what? 1/4 makes it 2, so
1 over
negative 1/4
Negative
makes it 1/2. Do you guys see that? I know 1/4 makes it 2. Now I just have to flip it also, so now I make it negative 1/4. The negative makes it flip. The 1/4 makes it 2. This one I already did. I know. Look at all these flies. This is crazy. What do you have to do with this problem? We did it earlier. What's written in the wrong form?
it's 11 to the 1/2.
There you go. And what's the answer? What do you raise 11 to get 11 to the 1/2? 1/2. 11. Or you can say these kill each other. Either way, you get 1/2. I like it. All right, I'm going to, yes.
So when you always see a problem like that, you always rewrite it
Yeah, if the inside's in power form, and that's what the log's looking for, that's why it makes sense. So if I have a radical inside a log, rewrite that sucker as a fractional power. Because the log is looking for powers.
How would you use E to like calculate populations? Or...
That's a whole separate. Say your population grows by like 2% a year, so there would be a 0.02 year, and it would be times the initial population, all this kind of stuff. So it's the only one where I can see the growth rate in it. That's really the reason we use E, and that's not the best answer at the moment, but there's a lot more involved. You with me? But that really is the reason why we use E, because then I can see the growth rate in it. I like it.
Do they cover this in more?
This is actually 1.02.
In calculus or?
Pre-calculus.
So,
Pre-calculus, you get a lot deeper into that. Yeah. All right, that's enough today, guys.